This is a LibriVox recording. All LibriVox recordings are in the public domain. For more information or to volunteer, please visit LibriVox.org. The Fairyland of Science by Arabella Buckley. Read and recorded by Patricia Oakley. Lecture 2. Sunbeams and the Work They Do. Who does not love the sunbeams, and feel brighter and merrier as he watches them playing on the wall, sparkling like diamonds on the ripples of the sea, or making bows of colored light on the waterfall? Is not the sunbeam so dear to us that it has become a household word for all that is merry and gay? And when we want to describe the dearest, busiest little sprite amongst us, who wakes a smile on all faces wherever she goes, do we not call her the sunbeam of the house? And yet, how little even the wisest among us know about the nature and work of these bright messengers of the sun as they dart across space. Did you ever wake quite early in the morning, when it was pitch dark, and you could see nothing, not even your own hand, and then lie watching as time went on till light came gradually creeping at the window? If you have done this, you will have noticed that you can at first only just distinguish the dim outline of the furniture. Then you can tell the difference between the white cloth on the table and the dark wardrobe beside it. Then by degrees all the smaller details, the handles of the drawer, the pattern on the wall, and the different colors of all the objects in the room become clearer and clearer, till at last you see all distinctly in broad daylight. What has been happening here, and why have the things in the room become visible by such slow degrees? We say that the sun is rising, but we know very well that it is not the sun which moves, but that our earth has been turning slowly round and bringing the little spot on which we live face to face with that great fiery ball, so that his beams can fall upon us. Take a small globe and stick a piece of black plaster over England. Then let a lighted lamp represent the sun, and turn the globe slowly so that the spot creeps round from the dark side away from the lamp until it catches first the rays which pass along the side of the globe, then the more direct rays, and at last stands fully in the blaze of the light. Just this was happening to our spot of the world as you lay in bed and saw the light appear. And we have to learn today what those beams are which fall upon us, and what they do for us. First, we must learn something about the sun itself, since it is the starting place of all the sunbeams. If the sun were a dark mass instead of a fiery one, we should have none of these bright cheering messengers, and though we were turned face to face with him every day, we should remain in one cold eternal night. Now, you will remember we mentioned in the last lecture that it is heat which shakes apart the little atoms of water and makes them float up in the air to fall again as rain, and that if the day is cold they fall as snow, and all the water is turned into ice. But if the sun were altogether dark, think how bitterly cold it would be, far colder than the most wintry weather ever known, because in the bitterest night some warmth comes out of the earth, where it has been stored from the sunlight which fell during the day. But if we never received any warmth at all, no water would ever rise up into the sky, no rain ever fall, no rivers flow, and consequently no plants could grow, and no animals could live. All the water would be in the form of snow and ice, and the earth would be one great frozen mass, with nothing moving upon it. So you see it becomes very interesting for us to learn what the sun is, and how he sends us his beams. How far away from us do you think he is? On a fine summer's day, when we can see him clearly, it looks as if we had only to get into a balloon and reach him as he sits in the sky. And yet we know roughly that he is more than 91 millions of miles distant from our earth. These figures are so enormous that you cannot really grasp them. But imagine yourself in an express train, traveling at the tremendous rate of 60 miles an hour, and never stopping. At that rate, if you wished to arrive at the sun today, you would have been obliged to start 171 years ago. That is, you must have set off in the early part of the reign of Queen Anne, and you must have gone on never resting through the reigns of George I, George II, and the long reign of George III, then through those of George IV, William IV, and Victoria, whirling on day and night at express speed, and at last today you would have reached the sun. And when you arrived there, how large do you think you would find him to be? Anaxagoras, a learned Greek, was laughed at by all his fellow Greeks because he said that the sun was as large as the Peloponnesus, that is, about the size of Middlesex. How astonished they would have been if they could have known that not only is he bigger than the whole of Greece, but more than 1,000,000 times bigger than the whole world. Our world itself is a very large place, so large that our own country looks only like a tiny speck upon it, and an express train would take nearly a month to travel round it. Yet even our whole globe is nothing in size compared to the sun, for it only measures 8,000 miles across, while the sun measures more than 852,000. Imagine for a moment that you could cut the sun and the earth each in half as you would cut an apple. Then, if you were to lay the flat side of the half earth on the flat side of half the sun, it would take 106 such earths to stretch across the face of the sun. One of these 106 round spots on the diagram represents the size which our earth would look if placed on the sun, and they are so tiny compared to him that they look only like a string of minute beads stretched across his face. Only think, then, how many of these minute dots would be required to fill the whole of the inside if it were a globe. One of the best ways to form an idea of the whole size of the sun is to imagine it to be hollow, like an air ball, and then see how many earths it would take to fill it. You would hardly believe that it would take 1,331,000 globes the size of our world squeezed together. Just think, if a huge giant could travel all over the universe and gather worlds all as big as ours, and were to make first a heap of merely 10 such worlds, how huge it would be. Then he must have 100 such heaps of 10 to make 1,000 worlds, and then he must collect again 1,000 times that 1,000 to make 1,000,000. And when he had stuffed them all into the sunball, he would still have only filled 3/4 of it. After hearing this, you will not be astonished that such a monster should give out an enormous quantity of light and heat, so enormous that it is almost impossible to form any idea of it. Sir John Herschel has, indeed, tried to picture it for us. He found that a ball of lime with a flame of oxygen and hydrogen playing round it, such as we use in magic lanterns and call oxyhydrogen light, becomes so violently hot that it gives the most brilliant artificial light we can get, such that you cannot put your eye near it without injury. Yet if you wanted to have a light as strong as that of our sun,